One of the most exciting directions in architecture today is the integration of advanced geometric forms that make structures both lighter and stronger. Geometry isn't just about aesthetics. It defines how efficiently a structure uses material, distributes loads, and withstands environmental forces. A striking example is the Schwartz primitive surface, a minimal surface defined by smooth curves and an intricate, porous lattice. Though visually complex, Schwartz surfaces are mathematically pure and surprisingly efficient. They maintain stability while reducing unnecessary mass. This geometry is not just theoretical. It occurs in nature. Bones, coral, and cellular structures rely on similar patterns to balance strength and weight. By mimicking these natural forms in our buildings, we can create structures that are light, strong, and inherently sustainable. With the advent of 3D printing, it is now possible to fabricate Schwartz surfaces in concrete, pushing the boundaries of structural design. These surfaces distribute forces evenly across their geometry, reducing stress concentrations and enabling material savings. The innovation doesn't stop there. When combined with graphene-enhanced concrete, the performance leaps forward. Graphene offers exceptional tensile strength, chemical resistance, and thermal performance, making the final product both durable and futuristic. Together, geometry and material create synergy, a high-performance, lightweight construction system that uses far fewer resources. This combination supports a bold new vision, architecture that is not only beautiful and expressive but also deeply sustainable. For architects and designers, this method opens up endless creative possibilities. Forms that were once impossible are now achievable, responsibly and efficiently. Schwartz geometry and graphene-enhanced materials represent a path forward, where form meets function, where material meets meaning.